Today's lesson is on dividing fractions. Up until now, we've been adding, subtracting, and multiplying fractions, but today we're going to tackle dividing them. Now, in order to show you how to divide fractions, we have to do a little mini lesson on something called reciprocals. I'm not sure if you ever heard of the word reciprocal, but in math, it's pretty simple to find one. So you see I have 3/4 here. The reciprocal of 3/4 is, I'm going to write it here beside it, 4/3. You just interchange the numerator and the denominator. Now, what's interesting about reciprocals is that when you multiply them, let's see what happens. 3/4 times 4/3. We're going to multiply the numerators, 3 times 4. That's going to give us 12. Multiply the denominators, we'll also get 12. And 12 divided by 12 is 1. Pretty cool. I could have also cross-canceled. If you would have cross-canceled these 3s and cross-canceled these 4s, you would have been left with a bunch of 1s, which would have given us 1/1, which is also 1. Okay, let's look at the next one, 2/5. Think about what the reciprocal of 2/5 is. Well, the reciprocal would be 5/2. What happens when we multiply them? 2 times 5, 10. 5 times 2, 10. And 10 divided by 10, 1. Interesting. How about 1/7? Well, the reciprocal of 1/7 would simply be 7/1. We multiply. 1 times 7, 7. 7 times 1, 7. Divide. Notice the pattern here. So let me guess. I wonder if we multiply 12 by its reciprocal, if it will be equal to 1. I'm thinking it will be. Let's see though. 12. What's the reciprocal of 12? Well, let's first start by putting 12 over 1, because that will make it much easier to find the reciprocal 1/12. 12 times 1, 12. 1 times 12, 12. And indeed, we get 1. So 2 new things you learned just now. You learned what a reciprocal is. Simply take a fraction and interchange the numerator and denominator. And you also learned that when you multiply 2 reciprocals, you will always get 1. This is going to come back into action in just a few minutes. Okay. So how do we divide 2 fractions? This is brand new. Well, I'm going to show you the steps first, and you're probably going to be thinking, why is that working? I'll show you the why after I show you the how, okay? So let's take a look at 2/3 divided by 1/6. Here are the steps. You take the first fraction, you do nothing to it, just leave it alone. You take the second fraction and you reciprocate it. So the reciprocal of 1/6 is 6/1. And the last part, you change the division sign to a times sign. I know, right? Why in the world are we doing this? Like I said, I'll show you the why in a minute. But for now, 2/3 slides down, don't change it. Take the reciprocal of your second fraction, it becomes 6/1, and transform your divided by sign to times. Now, you're going to multiply numerator to numerator. 2 times 6, 12. 3 times 1, 3. And 12 divided by 3 gives us a final answer of 4. You also could have done this by cross-canceling. 2 and 1 cannot cross-cancel, but you could have done the 3 and the 6. 3 divided by 3 is just going to give us 1. And 6 divided by 3 would give us 2. And so 2 times 2 would be the 4, and 1 times 1 would be 1. So you would also get 4 if you cross-cancel. Cool. So why in the heck do we do this? Why does that work? Let's take a look. The why behind this is pretty cool. So I wrote the same problem again, 2/3 divided by 1/6. What I'm going to do first to show you why this works is I'm going to write it a little bit differently. Let's take 2 over 3. And instead of using the divided by sign, let's do a big divided by bar and write the 1/6 on the bottom. So that's kind of like we've done in the past. If you had 12 divided by 4, you could also write that as 12 divided by 4. So that's all I did. I changed that division sign to this big bar. But what's really weird here is now we have a fraction divided by another fraction. And in math, this is called a complex fraction. And we don't like complex fractions in math. We try to get rid of them. The reason it's complex is it's a fraction, you have itty bitty fractions within this larger fraction. That's what makes it complex. Now, I'm trying to think of a way to get rid of all these fractions. Well, let's look at the denominator here, 1 over 6. I know the easiest way to turn 1 over 6 into just 1 is to multiply by the reciprocal. If you take 1 over 6 times its reciprocal, 6 over 1, do you remember what we get? We get 6 over 6, which is 1. So now instead of having the denominator as 1 over 6, my denominator is now 1. But if you multiply this denominator by 6 over 1, then to keep balance and equivalency, we have to multiply the top by 6 over 1. Wait a minute. So now we have 12 over 3, because the 12 here and the 3 here, which is 4, divided by, this divided by is this divided by. So we have 4 divided by 1, and the answer is 4. This part basically cancels out to 1, and it always will on the bottom. Notice what we did on the top. We have the same fraction, boom. We have the reciprocal of the back, boom. And we change the divided by sign to a multiplication sign. So if you followed that, this is the reason why, okay, bring that word back, why these are the steps to divide two fractions. Pretty cool. Okay, let's try one last example and we'll be done. Just one last example before we hit the road, just to review the steps one last time. 5/8 divided by 1/2. We bring the first fraction down, leave it be. We take the second fraction, find the reciprocal, 2 over 1. We change the divided by sign to times. And we could either zip zap here straight across, or we could cross cancel. I think I'll cross cancel since I can with the 2 and the 8. I can divide them both by 2. So 2 divided by 2 is just 1, and 8 divided by 2 is 4. 5 times 1 is 5. 4 times 1 is 4. That's improper. So let's long divide it, or do it in your head if you're getting good at this. 4 squeezes into 5 one time. 1 times 4 is 4. And we have 1 left over. So 1 1/4 is going to be the final answer. Good luck and happy trails to you.